Like, and it's an actual drive.
Okay. Alright guys, I am going to construct these real quick so you can see what they should look like, even if, in case you didn't get them.
I got the exit aisle and I guess.
Okay, I may not do them exactly the way you did them. I think there was a YouTube and there was another one. I'll show you one method, but probably not there. Okay, so. Alright, so construct an equilateral triangle. Alright, so what we're going to do first is we're going to just draw a segment. I think the directions you had said to copy a segment, so if you were given a segment to start with and you had to copy it, that was the directions they had. I'm just going to start with, this one didn't say we had to do that, so I'm just going to start with, here we go, there's my segment. And then I'm going to create the equilateral triangle from that. So what you would do is you would take your compass and place the point at one end, and you would measure down to the other. And then we would come over and arc. Oh, I did do it wrong. Let me go back and measure. I touched the wrong button. There we go. Now, you don't have to make the full arc like I do. You can just put the arc down here where you need it. And then we're going to switch to the other end of the segment, and we'll do another arc. And where those two arcs intersect is where your third vertex would be.
That's simple.
So, here's one vertex, here's another, and you just found your third. So then you will connect the dots, and you have your equilateral, equiangular triangle.
Wow.
Okay? That's the first one. The second one was a square. There's also a couple different ways to do a square. One way, whoops, I need to actually start with a center, is to start with a circle, and I'm going to start with my center so I can find it later. And I'm going to draw in my circle. There we go. There's my circle. Then I'm going to take my straight edge, and I'm going to go through the center of this circle and create a diagonal. Okay. There's a diameter of the circle. It's going to end up being one of the diagonals of the square. So, then I'm going to put in the perpendicular bisector to this line. So to do a perpendicular bisector, what do I have to do? I have to bring it out here. I have to go past the halfway point. I'm going to change the color real quick. And then we have to arc up and arc down. And then we switch to the other endpoint, and we're going to arc up and down. And then we can draw through those two. I missed it.
Oh, then where they intersect with the circle.
Okay, and then where they intersect the circle are the vertices of the square. So I'm going to make the square blue. No, got to do it blue here. I'm going to put the square blue. Ooh, I didn't draw that one well. I'll come back and do that one again in a second.
It looks good, Miss Wolby.
Anything.
It looks good. It looks good.
Okay, so do you see the nice blue square?
Yeah.
Okay, now where I did these big, huge green things, obviously your arcs don't have to be that big. It's just the only way I can do it with this software. All right, the last one was the easiest one, right?
Yeah,
The hexagon is nice and easy. So we're going to start with a circle. Okay, and then we're going to pick a point on the circle, any point, anywhere. And then we're going to take and measure the distance. Yours is already set, but I have to check again on mine. So there we go. Measure the radius. pin, and then shift. And if we did it all right, it should line up pretty closely. Look at that. Looks nice, doesn't it?
Looks
And
like
then you go back to those intersections, and I'm going to do mine in black this time. And connect the intersections, and when we do that, we have created our nice little regular hexagon.
that was so cool.
Where you make the arcs from?
See this?
You measure the distance from the radius to the circle. The same distance that you made the circle in. There's your hexagon. This hexagon looks better somewhere. There it is. Isn't that one prettier? That one's prettier.
Mine's a little off.
Okay, homework.
HW.
Take a look at your homework. See if you have any questions. I have number 55 worked out. Okay, let's not play with scissors.
So you go. Or it was me. We could find this.
No, I thought it was fine.
Oh, no, I know. Yeah, what?
Alright, check.
Oh my God, Miss Willoughby, I am on fire today. Figuratively.
Converse. Converse. We talked about it actually on Monday, but yesterday we did the problems that went with it. So the converse is what you would use if you're trying to prove parallel. Now, when we started with parallel, we'd say two parallel lines cut by a transversal, lots of stuff is congruent. Alternate interior, alternate exterior, corresponding are all congruent, and then same side or supplementary. Now, if we start with given two lines and you have same side, interior angles are supplementary, then you can state that the two lines are parallel. That is the converse of the same side supplementary. The same side interior angle is not supplementary. So the converse says, if this is true, then they must be parallel. The regular one says, if they're parallel, this must be true. So converse switches the if and the then part, the hypothesis and the conclusion. Switches the P and the Q. Yes, sir.
I put number 29. I put converse of the supplementary angles because when they equal.
Our four that we can pick are alternate interior, alternate exterior, corresponding, and same side interior.
Are we done with these?
Nope.
What do I say about exterior?
I have a question for you, Ben.
We don't usually use that, but they are supplementary.
I'm gonna cry.
Okay.
I'm crying.
Now, number 55, I don't know how many of you do the proofs in paragraph form. I would probably write it like this and say the measure of angle 2 is equal to the measure of angle 3 given. And then I'd say that angle 3 is congruent to angle 6 because vertical angles are congruent. You see I drew a little picture right here for those of you that don't have the book. And so because they're congruent, then the measure of angle 3 must equal the measure of angle 6. Definition of congruent angles. Alright, and then the measure of angle 2 plus the measure of angle 6 would have to equal 180 if we use substitution, right? Because what can I substitute in for angle 3? I can substitute in angle 6. And then I would probably say that angles 2 and angle 6 are supplementary. Now, the answer key doesn't say that, but I probably would. I would probably add that little statement right here, that angle 2 and angle 6 are supplementary, definition of supplementary angles. Therefore, line L is parallel to line M by the converse of the same side interior angle theorem. Okay? Any other questions you had about your homework? No? Fabulous. All right. Let's take our workbook, open them to page 71. There were several things you picked up on your way in, and the big sheet of paper, I want you to use about half of it when you do this activity. And each one of you do one, that way you have 4 at the end of the paper. Yes. 4 from there back. And then the 4 of them from there up.
Yeah.
Hey, Vito, let's go with somebody.
Roll it.
Come on.
Yeah, I know. I'm like,
You have 3 minutes.
Hey, we're here.
There's 4 Okay, 2 minutes and 30 seconds remaining.
we're doing this or should we use held back? We're doing this or the work?
Yeah, the back.
Page 71 in the workbook. Okay, this is scrap paper.
Oh, so it's on the back.
Nope. All it is scrap paper.
We're using the back of it?
Sure.
Oh.
I love my pen.
This was Evan's homework.
You could have just like, I thought last I'm not weird, okay?
Okay, so basically the directions said on your big sheet of paper, draw a fairly nice sized triangle with your straight edge. Then cut it out with your scissors. That's what it said.
I drew an obtuse triangle.
That's exciting. Just don't do a triangle just like your neighbors, because y'all are going to compare your triangles in just a minute.
You better not sign it.
I'm doing a right triangle.
If you're right.
If you build a triangle, protractor.
No, you did it right.
This is a sausage.
Check that out.
Okay, we got about 2 minutes.
Yeah, how about dumb apples?
Look, it is a 90.
Okay, we should be cutting them out. You have them out now?
Mine's a 91-degree angle, so it's one more than the right.
You mean a cute one?
Yeah.
Okay, I forgot to mention this in 5th period, but yesterday one of my compasses went AWOL. So,
What is a
No, it has to be this side.
someone, maybe accidentally took a compass home to borrow it and forgot to return it, or
I was
somebody
at court.
stole it on purpose, one or the other.
I wish I knew because
So let's make sure that gets returned because they actually do not belong to me. I borrowed them from someone else.
Why don't they don't return it?
You guys like my triangle?
Triangle is beautiful.
I will not be for it. I like that.
There we go.
Alright. Okay, follow those directions. Tear off the edges. I tear a pretty good bit. Don't just tear off like a little tip. That's hard to do. Do you see the picture it shows you? They tore off a pretty good chunk of it.
It's like a perfect chunk. Just
Oh, man.
Tearing it actually makes it easier.
Okay, that's what we.
That's awesome. Now,
What about this material?
I can't really tell which the arrowhead. I can understand that.
I know. After your movie.
Look at how
Alright, Evans looks good. Let's see if Ryan can put his together. Patrick's moving along nicely. Shelby's got it.
I want to compliment.
Jordan has hers just right.
Matt get off a little more than he could chew.
Donna has hers.
You like mine, Miss Willoughby?
Why don't you compliment us?
Because you're still playing with it, and I just make them rather large. And it looks like you've got miniature minute.
You like mine? You like mine?
Hey, Shelby's I just cut it off.
Angle style piece.
You know? Yeah, mine's
Mine was the
Look,
Okay. So, look around at all the people around you. When they rip their angles off and put them together like a puzzle.
I couldn't find out how to get
Yeah.
Yes, like a puzzle.
Just the angles, not the middle of the triangle.
Oh, yeah. Wow, Morty, do whatever I
Okay.
May I take my workbook?
Yeah. And we need it all to be this way. Alright, so what were you putting all three together?
You're the special one.
They made a straight line.
That's what all of you I'm following each other. High five. I'm doing it.
Alright. So, except for the group over here, where we have someone being not nice to their friends again. You guys did a good job. So no matter what kind of triangle you drew, some of you had some right triangles. Some of you had some that almost looked equilateral. Some of you had triangles that looked isosceles. We had lots of different scaling. We had some acute, some obtuse.
I was 91.
Okay? So we had all different kinds of triangles. But when we ripped off the angles, and we just took the angle parts and put them together like a puzzle, no matter what our triangle looked like to start with, when we put them together, what they form?
Straight
A
line.
straight line.
I got it right.
And what does that tell us about the sum of the angles of any triangle? It equals 180 degrees. Okay, you guys already knew that, didn't you?
Yeah.
But we just verified it, didn't we? Now we're going to verify it one more way. We're going to do a mathematical proof.
Oh, fantastic.
Okay? So, let's take a look. So this is what we just verified right here by physically ripping the angles off the triangle and putting them together. Now let's do the proof. Oops. Hold on. We'll start here. Okay, so this is angle 4 here. This is not labeled. And this is angle 5. Alright. So if you're given a triangle ABC, and you are also given that line AD is parallel to BC, are we all good with that?
Yes,
Could you draw that? Could you construct it? Yes. Alright, what we're trying to prove is that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Alright, so what would the first step be?
To state the given.
State the given. Okay, so the first thing is that we have a triangle, we don't really need that, but now let's state the other piece of the given, that AD is parallel to BC, and that was given. Now, when we have two parallel lines and they're cut by transversals, it tells us a lot of stuff. And on this one, what does it tell us is congruent? 4 is congruent to what?
5.
Try again.
1.
1. Why? Alternate interior angles. So angle 1 is congruent to angle 4. Anything else?
Oh, 5 and 2. 5
And 5 and 2 are congruent because they are also alternate interior angles. So I'm going to put them both in one step since I have the same reason here. And I'll say alternate interior angles are congruent. If two parallel lines cut by a transversal, alternate interior angles are congruent. Okay. Now, so I got that. Now, do you guys see that all three of these together make a straight line?
Yes.
But we don't have anything that tells us about putting 3 angles together. But we do know that if we put 2 angles together and it forms a straight line, what's that called?
A square.
A linear pair. Good. A linear pair. So I can write the measure, let me try that again. The measure of angle 4 plus the measure of what angle?
3. No, 1.
3 and 5 together makes what angle?
Got it.
BAD.
C.
BAD. The
Bad.
measure of angle bad equals 180 degrees because they form a linear
Linear.
pair. addition postulate. Okay, now, who sees where we're going? Where can we go now?
Measure of angle 4 equals.
We got
Never mind.
we got BAD and we got BAD.
That's good.
What is BAD equal to?
Oh.
BAD.
3 and
3, 5.
5. So now I can make the statement that the measure of angle 4 plus the measure of angle 3 plus the measure of angle 5 has to equal 180. How? I did use substitution.
Yes.
I substituted in.
Thanks, Ryan.
Okay. But I know that angle 1 is congruent to angle 4. So the measure of angle 4 would have to be the same as, as angle 1. And then 5 with 2. And then I already had 3. And I used substitution again, didn't I?
Yes.
And did I do it?
Yeah.
I did it. You might want to add a step in here that you definitely could put a step right here that the measure of angle 1 is the same as the measure of angle 4, and the measure of angle 2 is the same as the measure of angle, and I probably should have done that.
Well, it's not the same as number 1.
Nope. On those I said they're congruent, same size and shape.
Is that the same thing?
You're right. But if we were doing nitpicky proofs, we would want that one little extra line in there. Does that make sense? Yes, Evan?
You said in college you had like 3 proofs that added like 17 pages.
Yes.
I was just curious, what the heck were you doing with 17 pages?
I'll have to see if I still have my notes.
That sounds like it would be crazy.
It was fun.
Oh, that doesn't
Fun.
sound like it would be
To be.
Sounds like it would be an ant.
Yeah.
I understand.
They were fun proofs.
Okay.
Okay. Now, here we go. I think like 73, 74, somewhere around in there. What page number is this, guys?
73.
73. Okay, so page 73. A corollary. Here's a new word. I'm not going to test you on this word, but it's nice to have exposure to new vocabulary. A corollary is a theorem. A corollary to a theorem is a statement that can be proved easily using that theorem. So, we just talked about the triangle sum theorem.
I don't like
We proved it 2 different ways. We proved it physically by ripping our triangles apart, and then we did a geometric proof. So, we know that the sum of the 3 angles of a triangle equal 180, but this is a corollary to this theorem. And it's talking about the exterior angles of the triangle. So first of all, let's revisit what interior versus exterior. Well, interior makes you think inside. Good. And exterior makes you think outside. So the interior angles of a polygon are the ones that are inside the closed figure. The exterior angles of a polygon are the ones that are on the outside of the figure when we extend one of the sides. So this is an exterior angle. So when we're talking about triangles, if we extend one of the sides of the triangle, the exterior angle is here on the outside. And then specifically for this example, what we're talking about are considered remote. Well, remote means not close, right? Far away. So these two are called the remote interior angles because they're the ones that are further away from the exterior angle. And we're going to prove something about the remote interior angles. Okay, so this is example 3 in your workbook on the same page. We are given this triangle, ABC, and I guess it really should be labeled then. And we're asked to prove that the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. Now, my first statement right here says angle 3 and angle 4 are supplementary. Well, how can we just look at this picture? No matter if this is drawn to scale or not, angle 3 and angle 4 are forming what?
Linear pair.
A line. So they are a linear pair. And we know that the angles that form a linear pair must be supplementary. So when we add up those measures, because they're supplementary, they add up to 180 because that is the definition of supplementary. Now, the next statement is regarding the triangle sum theorem. theorem. What does the triangle sum theorem say?
That all the sides equal, or all the angles equal 180.
Good. When we add up the measures of all the angles, it's always going to equal 180 degrees, no matter what your original triangle looked like to start with. Okay, now do you see that this statement equals 180, and this statement also equals 180? So could I plug this in right here for 180? Because this is equivalent to 180? Yes. We can plug this in for 180, and then we get this fourth line. What did I use to do that? Substitution. Now, how am I going from this fourth line to the fifth? What changes over here and over here? The measure of angle 3. How do we make it go away? What do we do? Yes. We use the subtraction property of equality, and we subtracted the measure of angle 3 from both sides. So subtraction property of equality. Okay, so what did we just prove? We just proved that the measure of this exterior angle is always equal to the sum of the two remote interior angles. The outside angle is always equal to the sum of the two remote interior. So, if I told you that this one, angle 2, the measure of angle 2 is 70 degrees, and the measure of angle 1 is 60 degrees, what is the measure of angle 4? 130. Got it? The sum of the two remote interior is equal to the exterior. Okay, so then we might see them in some fun ways. If you flip over to page 75, we have some examples here. We're going to look at 6, we're going to look at 7. Okay, when I look at this problem, I know that the measure of angle A plus the measure of angle B has to equal what?
Angle B. No.
How many degrees?
120.
120 degrees. Because this angle formed right here, angle BCD, has a measure of 120 degrees. This is my exterior angle. A and B were my two remote interior angles. But because this is marked as what kind of triangle? Isosceles. What do we know about an isosceles
All
triangle?
sides are equal.
That's equilateral.
Oh yeah.
Isosceles, we're going to have base angles that are
Equal.
the same. So whatever one is, the other one is 2. So what are they both? 60. Okay, let's take a look at number 7. On this one, they gave us this angle here, PRS, and then they gave us the angle here at P and the angle at Q. What do we do? So we're going to set the exterior angle, 9x plus 2, equal to the sum of the two remote interior. So 23 plus 5x minus 1. So we get 9x plus 2 equals 22 plus 5x. So 4x equals 20 and x equals 5. Is that my answer?
No.
No, good. That's not what they asked me for. They asked me for the measure of this angle. So I'm going to plug it in. I get the measure of that angle is 47 degrees. Any questions? Okay, at the bottom of the page, there's a couple that have to do with all three angles of a triangle. Well, what would we do? We would add them up and set them equal to 180. So we're not going to spend a lot of time with that. I think you've already had a little practice with that. We're going to flip over to page 103 now. And I would like you to, in your same groups, I want you to quickly do this. So it says work on a separate sheet of paper, use a straight edge to draw an angle, any angle. Place the point of your compass on the vertex, then draw an arc. Use a straight edge to draw in a BC. And then use the protractor, which I hope all of you picked up, to measure
Oh.
Yeah.
D8. Now, real quick lesson on a protractor, because every class period somebody's asked me.
I know how to use one.
Good. Here comes my protractor. Okay, the first thing you do, if I'm going to measure, let's say I'm going to measure this angle right here. I'm going to measure looking up, going this direction. So what I do is I take and I line up the base and the vertex to that bottom line. Does everybody see that? And then I'm going to read along this other line. So I even get this little extra cool thing right here where I get to make it match up. Okay, do you see I'm reading the bottom numbers when I go this direction? That looks about 45-ish, maybe 43. So reading up, you read the bottom numbers. And I would say that was about 43 degrees. Now going the other direction, let's move it over here to this side. Let's say we're trying to do an angle on this side. So I'm going to take that, line that up. This time I'm reading from the other direction, so I'm going to read the top numbers. So I read the top numbers, and it looks like it's about 45. So here I read the bottom numbers going that direction. Going this direction, I read the top numbers. So counterclockwise bottom numbers, clockwise top numbers.
About 6 degree.
Oh, dang it. No.
No.
Okay, on the angle you made, what'd you notice about those two bottom angles?
They were the same.
Evans were the same.
Mine were.
Kyle's were yours close or very different?
Well, I just constructed an angle, so I didn't really have two basis angles. Matt just said which one constructs an angle. I didn't.
Okay, you're supposed to be reading these directions right here on page 103. Kyle, you got this.
What?
You need to listen.
Oh, they are jealous. I don't think
Oh, no, I don't think you do.
Yeah, I like myself better than I was thinking.
Okay, so what everybody should have noticed is, every time, no matter what your triangle looked like, whatever one of the base angles was, the other one was the same, or really close, because you're doing constructions, it might have been off just a hair. But it should be exactly the same. So, whenever we deal with an isosceles triangle, we have two congruent legs, and then the base angles are congruent. Now, this is kind of important because the SAT may use this verbiage. All right, recall that an isosceles triangle is a triangle with at least two congruent sides. The congruent sides are called legs of the triangle. The angle formed by the legs is called the vertex angle. And I have seen on released SAT questions where they said the measure of the vertex angle is 32 degrees, find x, when they put an x down here. So you need to know what the vertex angle is. The vertex angle is this angle here, formed by the two legs. The angles at the bottom are called base angles. Okay? Alright, so what everyone should have noticed is, if they constructed congruent legs here, that the base angles were congruent. We good?
Yes.
Alright. So how would we prove this? Okay.
Can you label a triangle?
So, given a triangle where AB is congruent to BC, we are asked to prove A is congruent to C. So AB is congruent to BC. Now let me label this correctly. Good. So step one, we're given this. AB congruent to BC. Get it. Now, what Okay. So, I drew in, I'm going to call this point right here where it hits D. I'm going to draw in BD such that it bisects angle ABC. So, is that fair? Can I create an angle bisector? Do you know how to construct an angle bisector?
Yes.
Okay. Now, when I bisect an angle, how many angle bisectors are there for one angle? One. And so that is our reason, and you wouldn't know that. Any angle only has one unique bisector. That's why I can draw it in, and there's only one of them. And so when I draw in the bisector, did I create congruent angles? Yeah. I created an angle ABD, and it is congruent to CBD. This is congruent to this. Do you see that? And that would be the definition of angle bisector. Okay, and BD is congruent to itself, isn't it? What property is that? Reflexive property.
And then CPT, CPTC.
Yeah, that is exactly what I'm about to use, but I can't use that until I prove congruent triangles.
Well, yeah.
ABD is congruent to CBD by what?
CPCT.
Side angle side. I said it first. Amen.
And now I can say that angle A is
CPCT,
congruent to angle C because corresponding parts of congruent triangles are congruent. Make sense?
Yes.
All right. Okay, so let's take a look at how we would use what we know.